Hello and welcome to ByteBuilder, where we turn AI theory into working systems. In this video, we will explore why a single AI agent is no longer enough and how multi-agent systems like CrewAI are changing the game. Think about it. One model trying to research, plan, code and reason all at once. It quickly hits limits. CrewAI introduces teamwork to AI, specialized agents that collaborate, share goals and complete tasks together. Let's start with the problem. When one agent handles every part of a workflow, reasoning, memory, tool use, and output, it becomes a bottleneck. The model slows down, repeats itself, or loses track of context. It's like one developer designing, coding, testing, and deploying all at once. CrewAI solves this by dividing responsibility, giving each agent a focused role so the system can scale in both accuracy and speed. So what exactly is CrewAI? CrewAI is a coordination framework that lets you build intelligent teams of AI agents. Each agent plays a specific role. A researcher finds insights, a planner organizes steps, a builder executes, and a reviewer ensures quality. The CrewAI orchestrator keeps them aligned toward a shared mission, just like a project manager connecting a development team. CrewAI doesn't replace your models, it organizes them. It works with platforms like OpenAI, Anthropic or Llama, creating a structured orchestration layer between your models and your applications. On top of CrewAI, you can build automation systems, dev tools, or research assistants, all powered by multi-agent collaboration. It's the bridge between isolated LLM calls and complete intelligent workflows. Now that we have covered the theory behind CrewAI, let's move into the practical side, building your first working CrewAI project. We will go step by step, setting up the environment, installing dependencies, creating your API key file, writing the code and running it together. By the end of this, you'll have a working multi-agent workflow on your machine. Let's start from scratch. First, create a new project folder. In your terminal, type mkdir, the name of the folder. Then we should go inside of this folder. Let's clear our terminal. And this creates a new folder where we will keep everything organized, our environment, code and keys. Keeping things isolated like this is good practice, especially when working with AI frameworks that depend on API keys. Next, let's set up a virtual environment. This keeps all dependencies for this project separate from other Python setups on your system. In the terminal, you have to type python -m and the name of the environment, which in our case will be crew_env. Now that we have created our virtual environment, we need to activate it. For that purpose, you have to type this command. And as you can see, our virtual environment is now activated and ready to be used. With the virtual environment active, let's install CrewAI and .env for key management. Let's type pip install CrewAI python-env and OpenAI. Before we execute this command, let's understand what it does. This command will install CrewAI, which is our main framework, python.env, which will help us securely load API keys from a .env file, and OpenAI will be our SDK that we will use to connect to the LLM backend. Let's execute it. After a few seconds, you will get an output like this, which will indicate that everything was successfully installed in your new virtual environment. Now, let's create our .env file to safely store our API key. In the root of your project, create a new file called .env. Let's do that. Once we have this, we need to put this line here. This will store the value for your real OpenAI API key. Replace sk your API key here with your real OpenAI key. Just make sure that this file should never be committed to GitHub because it's private. CrewAI will use this key to connect to your LLM provider when we run our agents. Now we will create our main Python file. Let's call it main.py. At the top, let's import everything we need from CrewAI and .env. We are importing these three CrewAI components: agent, crew, and task. Agents are the brain, tasks are the instructions, and crew is the orchestrator that connects them all. We are also importing vault.env, which we will use to securely load our environment variables. Now it is time to define our agents. Agents represent independent workers, each with a role, a goal, and a context. Here we will create two agents, a researcher and a writer. I have already prepared the code, so I will just paste it here. The researcher gathers facts while the writer transforms them into a structured content. Each agent is specialized. That's the key idea in multi-agent systems. Focused agents reduce confusion and increase reliability. Agents know who they are, but tasks tell them what to do. Tasks are the atomic units of work in CrewAI, clear, structured, and assigned to one agent each. Let's define two tasks, one for research and one for writing. I have already prepared the code for that. Notice how each task has a description, an expected output, and a assigned agent. The researcher will only work on the research tasks and the writer will only write. This design mirrors real-world workflows, like developers and writers collaborating in a pipeline. With the agents and tasks ready, we now assemble them into a crew, the structure that tells CrewAI how to run the workflow. Here is the code for that. Here we set the process to sequential. That means CrewAI will execute tasks in order. First the researcher and then the writer. CrewAI automatically passes context from one task to the next, so the writer receives the researcher's findings as input, no manual code is needed here. One thing that we forgot to do is to set verbose equals true for our agents. This will make sure that we get additional walks that will help us debug our application. We can set the same value in the crew as well. Now comes the fun part, actually running the crew. Let's add the final block of code. On the first line, crew.kickoff triggers the process. Now let's run our agents. For the purpose, we have to open our terminal and type python main.py. This will run our main file. Now that it has finished executing, we can check the logs. Here you can see how the agents interacted between each other and worked together to complete the tasks. At the end of the logs, you will be able to see the final output that we have requested. Let's take a moment to understand what just happened. The researcher agent analyzed the concept of multi-agent systems. The writer agent used that data to produce a polished, developer-friendly block. We didn't hard code the workflow logic. CrewAI handled everything. This structure gives you scalability. You can add more agents, for example, planners, reviewers, or testers, and CrewAI will handle the collaboration automatically. In this demo, we built a complete two-agent system from scratch. We installed CrewAI, configured the environment, created specialized agents, defined clear tasks, and ran the full workflow in sequence. This is the foundation for everything that we will build next. In the next video, we will add memory, tools, and reasoning, so your agents can research, plan, and build autonomously. Subscribe to ByteBuilder, follow the CrewAI Build Series, and keep building smarter AI systems together.